So a function f is continuous at x equals c, provided that f of c exists, limit as x approaches c of f of x exists, and the limit as x approaches c of f of x equals c. Okay? So what we're doing today is proving continuity at a single point. Similar to what we were doing on the warm-up, they told us only to look at x equals 0. So we're looking at a single point, and you're trying to prove these three things. Okay? The first thing that you're going to prove is that f of c exists. So that means if you plug in 7, you get a number out as the answer. 7 is the point that you're looking at, right? So if this is undefined, you would stop. If any of these are false, you can quit because it's not going to be continuous. So if f of c does not exist, then it cannot be continuous. You need to prove next that the limit as x approaches c of f of x exists. Okay? You are going to do this most of the time, usually by looking at the limit as x approaches c from the left of f of x and the limit as x approaches c from the right of f of x. There could be a scenario where you don't use left and right limits, but most of the time you do the limit from the left, limit to the right, show that they're the same to show that limit exists. And then the last thing you have to have happen is that limit that you found in part 2, so limit as x approaches c of f of x, has to equal the f of c that you find in part 1. So in order to show something is continuous, you have to very clearly prove that these three things have happened here. All right? For that. Okay, questions? All right. Okay. Now, let's first really quickly just talk a little bit about one-sided limits before we get all the way into this, because it's going to be a big part of what we have to do. If you are doing a one-sided limit, first of all, if the limit as x approaches c of f of x equals whatever L is here, then the limit from the left and the limit from the right both have to equal L. So if a limit from both sides exists, then that limit from the left or right would have to equal that same thing. So if you're asked to do a limit from the left or the right of just a regular type function, you really just want to do it like a normal limit, like it's from both sides. Because if you get an answer from both sides, then that is also the answer for the one-sided limit there. So for this, if we plug in -3, we're definitely getting a 0 in the bottom. So that would be 9 minus 15 plus 6. You'll get a 0 in the top as well. So you cannot solve this by direct substitution. You're going to have to use some sort of strategy. What would you guys suggest for this? Factor and cancel. So we're going to do the limit as x approaches -3 from the right of x plus 2, x plus 3 over x plus 3. Our x plus 3's will cancel. And then we'll just have to plug in that -3. So we'll get -3 plus 2, which equals -1. Now what we really did there is we did the limit from both sides. But if the limit from both sides equals -1, that means from the right it also had to equal -1. So if you see this in this manner, this is probably what you're going to have to do. Okay. Now, the place you're more likely to see limits from one side are piecewise functions. Okay, so in general, for a piecewise function, the left side piece is going to be written first, the right is going to be written second. They could mix that up, but in general, AP exam, they do not try to trick you on that by putting these out of order. They usually put whatever's furthest left first, whatever's furthest right last. If you have any functions in between, they're usually always in order. And I will do the same like on quizzes and tests for you guys. I'm not going to try to trick you up by making that backwards. So if I'm looking for the limit as x approaches -2 from the right of f of x, then -2 is my cutoff point between these two. And I'm approaching from the right. So which function should I use, the top or the bottom? It's going to be the bottom. Even though it seems wrong, because what do you notice over here with your condition? It's a greater than, and there's not an or equal to, right? We still use the bottom, because limits don't have to equal the value. It's what they approach, right? So we're going to use that bottom one. When you're doing a limit, you don't care about where the or equal to sign is. When we have to do, like, actually find f of something, then we do care. But for limits, we don't care. So we would say, I like to write it this way to be very clear. Limit as x approaches -2 from the right. I like to go ahead and say of f of x, which is the entire piecewise function. And then I like to show which piece I'm using by doing this. Limit as x approaches -2 from the right of 3 over x plus 1. I think that it would probably be okay if you started out by writing that second one. I kind of like doing this to show, you know, it means the whole piecewise function, then you're showing which one you chose. You kind of already knew that because that's what they asked you up here, so I'm not going to count off if you don't write that first part. I like to see it there, but it's okay if you don't have it. And so this is just a direct substitution problem. Most of these limits are not going to be terribly difficult. They're going to be pretty simple limits that are within this, and you're just going to have 3 over -2 plus 1, which is going to give you 3 over -1, so you get -3 as your answer from the right. Okay, questions there? Mm-hmm.
So, we're learning to prove if they graph.
We're getting there, but these particular problems are just one-sided limits right now. We're working up to it.
So, what does it actually like mean in the graph?
It means you could trace the whole thing without ever having to pick up your pencil. So no holes, no vertical asymptotes, no discontinuities. Now, we're doing it just right now today at a specific point. So you're just basically proving there's no discontinuity at that point. Yeah. Okay. Now, let's look at this last one. It's actually not a one-sided limit, right? This is asking you to find the limit as x approaches 3 of f of x. That means both sides there. So in order for a piecewise function, which is what we're going to see a lot of today, in order to do this, you need to find the limit from the left and the limit from the right. So now in this particular case, I do want to see you do the limit as x approaches 3 from the left of f of x. And then, because that's not what they were asking you for in the first place, right? They wanted the limit as x approaches 3 of f of x. So you need to write this to show them, hold on, I'm only doing the left-hand side right now. So on 2, you could get away without writing that first step. On 3, I want to see it. And then you'll have the limit as x approaches 3 from the left. From the left, which function should I use, the top or bottom? Top. So I'm going to use 2x plus 5. Most of these are going to be simple direct substitution problems. So 2 times 3 plus 5 is going to give us 11 from the left.
You do like difference
Now, I know you could like,
I was going to say, you need to specify that's the left side, but you have it.
yeah, you've got it right here. And then from the right, we're going to do the limit as x approaches 3 from the right of f of x, which from the right-hand side, we need to use the bottom function, which is 14 minus x. Again, another just direct substitution. Minus 3. What do we get for that? 11. Also, since those equal each other, we can now say that the limit as x approaches 3 of f of x equals 11 as well. Did we use this in pre-cal, these 3 dots right here that meant therefore? So you can use that if you want. Therefore, the limit as x approaches 3 of f of x equals 11.
I'm pretty sure you use the dots on it.
Did you use the dots on your exam?
I feel like
Yeah, that symbol right there. Wonder if my work over here's got some 3 dots. Three. I don't know. I got a lot of. I had 81 on that test. I probably had a 90 in abstract algebra. That probably was my high.
That counts.
Yeah. Okay. Okay. So, let's prove that this function is continuous. Okay. So if we're trying to prove that this function is continuous, on that first slide we had 3 things we've got to show, right? We must show that f of 2 exists. We got to show the limit of as x approaches 2 of f of x exists. And then we have to show that those 2 numbers that we got are the same, right? So for I would do f of 2 first. It's just the easiest one to do. So and if you don't do it first, it's really easy to forget it at the end because the limit's where you do all the work. And then you forget that you got to make that conclusion at the end. So for that first thing, I'm just finding f of 2. Now, for f of 2, which equation should I use, the top or the bottom? Top. How do I know? The or equal to. So I care about that whenever I'm plugging the number in. I don't care about it for limits, but I do care about it for this. So I'm going to do 3 times 2 minus 4, and that is going to be 6 minus 4, which will give us 2. So that's the first thing that we've got to prove. You don't have to number them like this, but it might not be a terrible idea to number them to make sure you're getting all 3 of the things that you need to prove there. Okay, second thing you got to show is that the limit as x approaches 2 of f of x exists. For a piecewise function, to do that, you've got to do the limit from the left and the limit from the right. If they're asking you about the break-in point of the graph, which is probably what they're going to ask you about because it's the most interesting part to ask you about continuity of. So if they ask you about continuity at like 0, you just plug 0 into this equation. You don't do anything. It's all right there, right? So they usually ask you about the break-in point of that piecewise function. So if I do the limit as x approaches 2 from the left of f of x, which equation do I need to use? Okay, so I got the limit as x approaches 2 from the left of 3x minus 4. And for this, I'm just direct substitution, 3 times 2 minus 4. I realize I just did that on that last problem, and it feels very repetitive, but you want to do that again. Okay. Now that's just from the left. We've got to do from the right. Okay. From the right, you would use the bottom equation, 2x squared minus 6, and that's going to be 2 times 2 squared minus 6. And 2 squared is 4 times 2 is going to give you 8 minus 6, which is 2. So does our limit exist? Yes. And what does it equal? 2. So I'm going to say, therefore, the limit as x approaches 2 of f of x from both sides equals 2. I was seeing this the other day in my Facebook group. I think you can get away without making that last conclusion. Like if you just show limit from left and limit from the right and show you're getting the same number, you can get away without making that last conclusion. It's a good thing to do here, though, just to be very precise with it.
The 2 squared times 2, you square the inside first and then multiply by 2.
Yeah, square first and then multiply by 2. Because order of operations, you have to do exponents before you multiply for that. Like, please excuse my dear Aunt Sally, PEMDAS. Yeah. All right. And then the last thing you need to do is show that f of 2 equals the limit as x approaches 2 of f of x. And you can just say that because they both equal 2, they're equal to each other, right? So since you get 2 up here, you get 2 down here. Those are both the same. And then finally, you can make your conclusion once you've proven those 3 things. Therefore, f of x is continuous at x equals 2.
Is the at symbol a math term?
It's not so much a math term, but it is pretty much universally accepted to mean at, so
Use it?
they would take it on the exam. Yeah, it'd be fine for that. There is no specific list of things that they will take, but if it's widely used, again, I encourage you just to go ahead and spell things out, but if you abbreviate increasing with INC period, they're probably going to take that on the exam. Yeah, if you're really in a hurry, if it's very obvious, most any person would know it, they're probably going to take it. Now, if you prove a horizontal asymptote with Bobo Botno equals CC, they are not going to give you any credit for that, because that's nonsense that I don't know that. I know my high school teacher taught me that, and that Coach Wood used to always do it too. But where that came from, it could be like some sort of weird regional thing that everybody around here went to a workshop 20 years ago and started using that. I don't know. So, you definitely don't want to use anything obscure. But if it's really common to use it as an abbreviation, it's probably going to be fine. Okay. I, for some reason, gave almost no room to do example 5 and 6 right here. So if you want to use a different, I'm going to give myself more room by making some more space here. I realize you cannot do that. So you can either try to squeeze everything in that little tiny space. I didn't spell continuous right either. So you can either try to squeeze it in there, or if you want to get a separate sheet or something, that's fine too. All right, so this piecewise function, all 3 pieces are continuous, but it's asking you to show that the function is continuous at -3 and then at 5. So for -3, which pieces of the function do we need to use? The top 2. So to prove this, I always try to start off with f of -3, because if you don't, I a lot of times forget to do it. I get caught up in the limits and I forget to do it. So f of -3, which one do I use, top or bottom? Top. And what does it equal? 2. All right, so that's all I've got to do right there. Then, for the second thing, I need to do the limit as x approaches -3. And to do that for a piecewise function, that's going to be limit from the left and limit from the right. So I'm going to say the limit as x approaches -3 from the left of f of x equals the limit as x approaches -3 of just 2. And what is the limit as x approaches -3 of 2? It's 2. Okay. I must also do the limit from the right. So limit as x approaches -3 from the right of f of x equals the limit as x approaches -3 from the right of, this is going to be the middle equation, 2x plus 4. And that's a direct substitution, 2 times -3 plus 4, which is going to be -6 plus 4. What's that going to give me? -2. Does the limit as x approaches -3 of f of x exist? It does not, because you're not getting the same number from both sides. So this question, notice, didn't say prove. It said, is it continuous? Justify your answer. So it's not continuous. So we're going to say, therefore, the limit as x approaches -3 of f of x does not exist. And if any of the parts fail, so if f is not defined, if the limit does not exist, or if both of them are defined but they don't equal each other, then it's failed and it's not continuous. So we don't have to worry about whether or not these two are equal, because we can't, because it's not continuous. We're going to skip down to the conclusion. I'm going to use another therefore. F of x is not continuous at x equals -3. I'm going to clone this page. Okay. Questions on that part? All right, I've cloned that page. I'm gonna get rid of all this so I can still see the equation better to do number 6. Get rid of all this. Okay. Now for 5, which 2 pieces of the equation do I care about for 5? The bottom 2. So always start with, it's a good practice to always start with f of 5. Which equation do I use to find f of 5? Middle. 2 times 5 plus 4 is going to give us 10 plus 4, which will be 14. Not too bad there. The second thing we need to do is check that that limit exists. So we can show the limit as x approaches 5 from the left of f of x is the limit as x approaches 5 from the left of 2x plus 4, which is going to be 2 times 5 plus 4, which also gives us 14. And it is okay, like if you just want to say, if you skip some of that plugging in an arithmetic part, like for example, if you were to skip this part or maybe this part right here. It is okay to do that because the AP exam is going to assume that you were smart enough to plug that in your head and did not need to write it down. So it's important. You have to have like all this labeling stuff over here. If you leave that off, you wouldn't get full credit. But if you skip arithmetic because you're doing it all in your head, then they're not going to count off for that. Okay? And then so we got to do the limit as x approaches 5 from the right of f of x. It's going to be the limit as x approaches 5 from the right of the bottom equation, 2 times the square root of 3x plus 10 plus 4. And that is going to be 2 times the square root of 3 times 5 plus 10 plus 4. This one is going to require me to write down a little more. 3 times 5 is 15, plus 10 is 25, so you got 2 times the square root of 25 plus 4. What is the square root of 25? 5 plus 4, and what are we going to get? 14. Okay, so we got the same number here. We got the same number for everything. It's good to say, therefore, the limit as x approaches 5 from both sides of f of x equals 14. But if you left that off, you could get away with leaving that off. But you do have to show the last step right here where we say f of 5 equals limit as x approaches 5 of f of x. Now, it's acceptable to do this last step without showing what that stuff equals because you've already done that up here. You can't just write this without ever showing what those values are and it be a proof, but as long as you've done the first two parts, you don't have to show that's like 14 equals 14 or anything there. And so since we've met all of our conditions, we're going to say, therefore, f of x is continuous at x equals 5. Okay, questions? All right, we were pretty clearly not going to get through all of this. Oh, wait, let's see. It's okay if we don't do 7 or 8. Because there isn't, whenever I switch to the new, like the way AP does the new order a few years ago, there's a whole section on removing discontinuities. So 7 and 8, we're going to do those whenever we remove discontinuities. All right, let's see here. In fact, I'm going to hold off on all this right here. Yeah, I'm going to hold off on that. Okay.